Let's talk about the next problem that deals with derivation of equations using the concepts of dimensional analysis. Over here we have a problem that says the frequency of vibration of a string, which is small f, depends on the length L between the nodes. Nodes are the 2 points under which the string is tied, the tension F in the string and the mass per unit length small m. Guess the expression of its frequency from dimensional analysis. Now here we must understand that F is the frequency which has a formula of 1 upon time period. Now L represents the length of the string, tension F is the force, so it has the dimensions of force, and mass per unit length small m will have dimensions of mass upon length because it's mass per unit length. Now once we know this basics, we essentially have to establish a relationship between frequency and the things that it depends on. So for that, we'll start with the same method that we'll write frequency is proportional to each of the quantities raised to an arbitrary power, which is over here A, B and C. Now over here, if I have to remove the proportionality sign, I'll multiply it with K, which is the constant of proportionality, and we'll get an equality like this. Now with the concepts of dimensional accuracy, the LHS and the RHS must have the same dimensions. So we'll identify the dimensions of each side and then we'll equate them. Now over here on the left hand side, we have a dimensions of frequency which is 1 upon time period, and it has a dimension of 1 upon t. Now on the RHS, we have the dimensions for force is ml t raised to power minus 2. We get this from the formula F is equal to mass into acceleration. Next we have length, which has the dimensions of L, and then we have mass per unit length, which has the dimensions of m upon L. Now each of them have been raised to power A, B, C. That's exactly what we raised these quantities to in the second expression. Now if we rearrange the terms, the final expression we obtain is m raised to power A plus C, L raised to power A plus B minus C, and T raised to power minus 2A. Now once we have done that, we can equate this RHS with the dimension we had on the LHS. So doing that, we see T raised to power minus 1 is equal to this. Now over here we don't have any terms for m and L, so we can assume them as m raised to power 0 and L raised to power 0, because anything raised to power 0 gives us 1. Now if we compare the exponents on both LHS and RHS, what we obtain is A plus C is equal to 0, because A plus C is simply m raised to power 0. A plus B minus C is 0, because L raised to power 0 is also there, and minus 2A is equal to minus 1, because minus 2A is the exponent of t. Over here it's minus 1. Now once we equate these quantities, we obtain A as half, B as minus 1 and C as minus half. So carrying ahead, our final equation becomes K into square root of F into 1 by L into 1 by square root of mass per unit length. Now what we did here is we went back to the original equation and we put the value of A, B and C in the original equation. Now if we rearrange the term and write it nicely, we get frequency as K upon L into square root of F by M, which is our answer. K over here is a dimensionless constant. The value of the same we can obtain by experiments. I hope this is very clear to you. Thank you.